Alright, so we're back with lesson 2.11, and in lesson 2.11 we're going to identify solutions to quadratic equations, and we're going to solve these quadratic equations using what we call the quadratic formula. Okay, so let's go ahead and jump right into it. Alright, so first of all we're going to start up with a warm-up like we always do, and so our directions say to simplify the following. And so here we have I to the 21st power, and so we've learned previous that if I want to find a value, okay, because I know that I have I to the second power is equivalent to -1, I to the third power is equivalent to -I, and I to the fourth power is equivalent to 1, and we know that the i's start to just repeat the cycle. So if I'm looking for values where the exponent on I is greater than 4, then I'm just going to use the remainder to try to help me. So what I'm going to do is I'm going to take my highest cycle, which is 4, and I'm going to divide that number by 4. So I'm going to say 4 divided by 21, and I see how many whole times that 4 can go into 21. If I didn't know this, I'll use my calculator. So I'll put 21 divided by 4. Okay, and I get that it goes in there 5 whole times. So 5, it's just going to give me 20. And I'm going to have a remainder of 1. So it tells me that I to the first power is equivalent to I to the 21st power. And quite naturally, it's just equal to I, okay, or the square root of -1. Okay, same thing for I to the 58th power. I'm going to take the 58 and I'm going to divide it by 4. So I'm going to do 58 divided by 4. And I get it goes in there 14 whole times. Okay, so 14 times 4 is 56. Okay, so this time I have a remainder of 2. So this lets me know that I to the second is equivalent to I to the 58th power. And I to the second power is just -1. So this is just -1. All right, let's take a look at some more examples. All right, so here we are simplifying these radicals. And we learned that when we have a negative under the square root, that negative just tells us to pull an I on the outside or in front of it, and I'm going to put that lowercase I because it lets me know that this is an imaginary number, okay? And so this is equivalent to, now I have this I on the outside of the radical, and 81 is inside. Now, since now this 81 is a positive 81, I can take the square root of 81 very easily. So I know that the square root of 81 is just 9, so it becomes just 9 times I, okay, because the I is already on the outside. All right, taking a look at this one, it's a negative square root, so I got to get rid of that negative. I'm going to pull out an I, and so this becomes I times the square root of just 8. Okay, so I'm going to simplify just the 8. So I'm going to say equal. I'm going to keep that I on the outside. And when I simplify or I factor out the 8, I see that it can factor out into 2 times 2 times 2. Okay, if you want to check it, you can go ahead and check it. All right, so I have a pair of 2 now. So that means I can pull out a 2. So therefore, this is equivalent to 2I, because now the 2 is on the outside. So you brought out a 2 along with the I. So 2I times the square root of 2. And this is completely simplified. Okay, so today we're getting into solving quadratic equations. And first, we're going to look at solving these quadratic equations by graphing at first, just to kind of give you an idea of what it means to really solve an equation. So let's start off with this word problem. So it says a toy rocket is fired into the air from the top of the barn. Its height, which is represented by h, okay, above the ground in yards after T represents seconds, okay? So I want you guys to know that when we look at the equation, the T is going to represent seconds or time, and the H is going to represent the height, okay? Given the function H of T is equal to, well, everywhere in here I see a T, I know that that's indicating something about time, and this H is telling me something about height. So I have this function here. Okay, and first of all, it says to sketch a graph of the function using your graphing calculator. All right, so we know that it's very easy for us to go to Desmos and sketch these functions. So in Desmos, I'm just going to plug this information in. So I'm going to go, it says H of T, but instead of putting H of T, I can use just Y. But for here, I'm just going to use Y, okay? So Y equals, no, I'm going to use what they told us to use. So it is F of H of T, okay, equals -5. And then we have T, and that T is squared. And then it is plus 10T, oops, that's lowercase t, plus 20. Okay, and I just put it in just based off how the equation is. But looking at this equation right here, now I have sketched it. Let's zoom out a little bit. It's getting a little crazy. Okay, so zoomed out. So I sketched this, and so over here you guys should see a copy of your graph sketched, and quite naturally you can indicate some key things about this graph. We have the vertex, which is here, and then you also have your y-intercept, and you also have your 2x intercepts here. Okay, just some key things that we've been talking about with quadratic functions. Okay, so now let's go here. It says, let's select this. Okay, it says, what was the initial height of the rocket? Okay, the initial height of the rocket, we're looking at before the rocket was ever launched into the air. Where did the rocket start at before it was launched into the air? And so quite naturally, we remember, and I'm going to write this here, that the H is like your Y, okay, in this case, because the H is representing the height, okay? And so in order to find the height, I have to look at my y-axis, okay? And the T is representing the time. In order to look at the time, I got to refer to my x-axis, okay? All right, so if I'm looking for the initial height, that means before the rocket was launched, that means no time has went by. So my coordinate would be for my initial height, it should be at, let me take all these off, it should be at 0.20. So the initial height of this rocket before it was launched is at just 20. That was the height. And then it says, when did the rocket reach? Okay, notice here it says when. So of course that when, we're talking about time. Okay, so when did the rocket reach the maximum height? So I see the rocket started here. Okay, so it went up, it was launched into the air, then boom, it hit this height right here. Okay, and as you can see quite naturally at this point, which some of you guys will notice that this is a vertex. Okay, and you see you have 1,25. Well, the 1 represents, it says after 1 second, okay, I was at a height, the rocket was at a height of 25. So when did the rocket reach its maximum height? After 1 second. So we'll say at 1 second. Okay, and remember the t is the time, but we always have to look at our x value or our x-axis to refer to the time, and we always look at our y-axis or our y values to refer to the height. All right, the next question says, what was the maximum height? So now they're asking us what was the actual maximum height. So they want us to know the maximum height. And so here, quite naturally, the maximum height is 25. Okay. Remember, the 1 is the x coordinate, so that represents the seconds or time. And the y, which is 25, that represents our height if we go back to this little key here. Okay, now how long was the rocket in the air before it hit the ground? All right, now we have to first find out when did it hit the ground? Okay, when did the rocket hit the ground? So if I look here, I see that the height, because remember this y is going up, is going up, is going up, and then what is it doing? It's falling down, it's falling down, it's falling down, it's falling down, it's falling down. And so here is when it actually hits the ground. Okay, so how long, meaning time, was the rocket in the air before it hit the ground? And it looks like it was there for about 3 seconds. We'll say 3.2 seconds, okay? 3.2 seconds that it was in the air before it actually hit the ground. And then it says, at what times will the rocket be at a height of 22 yards, okay? So again, we're talking about, and I guess I forgot to put that, but these are yards because that's what the rocket's measured in. Okay, so the height is measured in yards and the time is measured in seconds. But it says at what time will the rocket be at a height of 22 yards? So that's saying when will my y be 22? And so I see my y is 20 here. So when will it be 22? What I could do is I could go over here, I can get a table, and so I want to know when am I going to have a 22 in this particular spot right here. Okay. Okay. So at what time will the rocket be at a height of 22 yards? Okay, so there's several different things, and let me kind of show you what they're saying. Okay, so of course, quite naturally, we know that the equation for this is h of t, okay, where the height is a function of time, and we have negative 5t squared plus 10t plus 20. Okay, so in this particular case, it wants to know when will this, okay, which represents the height, be equal to 22 and 5t plus 10t. Okay, those t's and the plus signs get confusing. Plus 20. So this is what it's asking us. So essentially, this is where we're going to get into how can we use the quadratic formula to help us to solve this, because I can go to the table, and what I can do is I can plug in values and numbers into the table. Let's say I see that when it's 1, between 0 and 1, between 20 feet or 20 yards and 25 yards. So I know it has to be less than 1. So I can just play with some numbers. I'm going to start with 0.5. And so I see at 0.5 seconds, I'm at 23 feet. Well, that's a little bit more. So I'm going to put 0.25. And so I got a little bit closer. But you can see that this is just allowing me to guess and check. And so if I want to be more precise, I can use what we call the quadratic formula, and I'm going to show you how to do that, which is going to allow us to find these values for t, okay? It's going to allow us to solve this equation for t. All right. So let's take a look at an example and see what the quadratic formula is all about. All right. So what is another method we can use to solve quadratic equations? And that is using the quadratic formula. Okay. So the quadratic formula, okay, or given an equation written in standard form, you have where you have a times x squared plus b times x plus c, which doesn't have a variable, and we have to always make sure that that's set equal to 0. When it's set equal to 0, then we can solve using this quadratic formula. Now, the quadratic formula says x is equal to negative b, okay, that's a negative in front of the b, plus or minus the square root of b squared minus 4 times a times c. And if you notice, my division line it goes all the way across, okay? And then I have 2 times a. Now, the b, the a, and the c, of course, quite naturally, we're going to be taking values from a quadratic equation, and we're going to substitute those values in, okay? That's why they're highlighted. So everywhere you see an a, whatever value is a, you're going to substitute that in. Wherever you see a b, you're going to substitute that in there, and you're going to substitute c in. Okay, let's look at an example so you can see exactly what I'm talking about. Okay, so first example, it says, looking at the example that we did before, okay, we've actually, if we come over here, we actually solved it, and we got these two solutions here. Okay, and in this particular case, these solutions was where they cross the excuse me, is where they cross the x-axis, okay? And so quite naturally, you can see where y is 0, okay? So when I am solving this equation using the quadratic formula, I have to make sure that my y is equal to 0. So I'm going to make my y equal to 0, okay? And I'm going to put negative 5t squared plus 10t plus 20, okay? So now what I have to do is I have to get my values. So you need to know, and you have to remember that your a is always connected to your x squared term. So the a is not going to be the variable. The a is just going to be the number that is attached to the variable. So in this case, my a would be negative 5 because it's attached to the t squared. And the big thing is the squared. My b is just going to be the positive 10 because 10 is attached to the t. So my b value is 10. And then your c is always the value that doesn't have a variable connected to it, which in this case, it is positive 20. Okay? Now, that's something very important that you guys need to understand. So now, what I would like for us to do is I want us to take those values, and we're going to substitute those values into this equation here. So if you remember that your a was negative 5, your b was 10, positive 10, and your c was a positive 20. So in this equation, all right, where I know that first a b is going to go here. So I know that positive 10 is going to go here, positive 10 is going to go here, okay, and those are the places where I'm putting my b at. Then I also know, and I guess let me change the color so to make it correlate. So that's 10, that's 10, okay, and then I know that a, which is negative 5 is going to go here because that's a, negative 5 is going to go here because that's a, and lastly, c is going to go here. Okay, so this is the first thing you have to do, is just make sure that you substitute your values into the formula correctly. All right, so next, once you substitute your values into the formula, we want to simplify this. Okay, and what I mean by simplify this, I want to, instead of taking all of this stuff right here along with me, I want to simplify it in sections. So quite naturally, you see that how this says -10, okay? This is one section that we're going to simplify. And let me get another color. This is another section that we're going to simplify. And this is another section that we're going to simplify. There's 3 different sections. So the first section that we simplify, it just says that x is equal to -10. So I just wrote a -10 because it says minus a 10. So therefore it's going to make that a -10, because that's like saying -1 times 10. And then I put the plus and minus sign down, and then I'm going to draw my square root. Okay, so now I need to take all of this stuff that's under the square root, and I'm just going to plug it into my calculator. So I'm going to open parentheses, put a 10 in there, close parentheses. I'm going to square that 10. Then I'm going to put minus 4, open parentheses, -5, close parentheses, open parentheses, 20, close parentheses, and I'm going to hit enter. And you see you get 500. So therefore, 500 goes under the square root. Then you divide this, okay, by 2 times a. This is the last part that you need to simplify before you can move on. So 2 times, or let me do this, 2, open parentheses, -5, close parentheses, and you get -10. So now I have a -10 out here. Okay, so when you go to your next step, this is what you start with. So we got -10 out here, we got 500 under here, and then we also have a -10 out here. That's what we got when we simplified the 3 sections. Now we want to move it a little further, because some of you guys notice that now I'm going to highlight this. I can just simplify this portion. Well, how do you simplify it? You just have to make sure that you break it down so that you pull out your perfect squares like we've been doing for a couple of weeks. So if I don't know factors, I can go over here to my y equals, and I can put 500 in there, divided by x, okay? And that's something that you guys have to remember if you're planning on utilizing this to help you, okay? And so quite naturally, I see a perfect square. I see 5 and 100, so I'm going to use 5 times 100 under here, okay? And also I'm going to have, let's see, what do we got? 5 times 100, and then we still have the -10 out here, and we have the -10 that's below. So quite naturally, you see that 100 is a perfect square. You can break that down into 10 times 10, but I'm not going to do that because I think you guys know how to do that by now. So this is x equals -10 plus or minus, okay, we leave that plus or minus there. So it's plus or minus 10 times the square root of 5, and it's still divided by -10. Okay, now at this point, we have division. So you have this division problem where you have to make sure that you simplify this. And basically what it is fractions. So I'm going to divide these two. And I also have to make sure that I'm able to divide these two, because these are whole numbers. And notice I circled the whole numbers. Okay, so when I divide -10 divided by -10, if you put that in your calculator, -10 divided by -10, you should get, well, I guess I gotta go to the actual, okay, so -10 divided by -10, I just get 1. So guess what? A 1 is gonna go here. And then I do 10 divided by -10, and I get this time a -1. So therefore a negative is going to go out in front of there. And then that 5 stays under the radical. So therefore what you just did was you were able to get rid of the fraction by dividing the 10 into both of these terms, okay, that was separated by the plus or minus sign. So now the 10 kind of goes away because you divided it. So you're left with 1 plus or minus negative square roots of 5. Okay, and so essentially this plus or minus just tells you that you just have two solutions. Okay, now most of the time you'll see it written like this, and it's perfectly okay, but you can also understand that your two solutions would be x is equal to 1 plus the square root of 5. Let me correct that. So it actually should be x is equal to 1 plus negative square roots of 5. And then also your other solution should be x is equal to 1 minus a negative square roots of 5. Okay? And you can make that into a positive by combining those together. But I wanted to write this out exactly like this. And if you want to clean this up a little bit, you can just write it as 1 minus the square root of 5. And over here, you can write x is equal to 1 plus the square root of 5. Because you have a negative and a negative that are next to each other and they make a positive. And here you have a positive and a negative. Well, the negative sign just can kind of take over. But just in case if you guys didn't see that, I wanted to let you know where that came from. And so quite naturally what I want to show you is that this. Okay, so I'm going to take my, and that's an equal sign there. Okay, so I want to take one of my solutions here, which is 1 minus the square root of 5. I want to put that in my calculator and show you that I got negative 1.23, okay? And then I want to do 1 plus the square root of 5 and show you that I got 3.23. Now, here is the really cool part about it is that, look, these are your solutions right here. These same solutions that I got with using the quadratic formula are the same solutions that show up here. But sometimes they like to leave your answer choices written like this in radical form where they don't want to see the decimal numbers. But if you know that they're equivalent to each other, then you kind of understand what you're doing. So all we did was graph the equation and we were able to find where the solutions were, okay, in which we recognize that where they cross the x-axis are our solutions, okay, and that's where you need to, that's what you need to know. So where the function cross x-axis are called our solutions. Okay, and so this is basically it. But sometimes what you're going to see is what happens when the graph doesn't cross the x-axis at all. And we're going to talk about and discuss that a little bit more, but I want you guys to have a little bit of practice with working with the quadratic formula and understand it a little better. Okay, so I have some U-try problems that I want you guys to try on your own, and then we'll come back tomorrow in class and discuss it.